Let's look at 8.3, example 1. So in this question, we're going to be asked to use our quadratic function in standard form. So standard form is ax squared plus bx plus c. And here's our equation here, f of x equals 2x squared plus 8x minus 1. So this is definitely in standard form. For part A, we're going to find the axis of symmetry, and part B, we're going to find the vertex of this quadratic function. So our first step to find the axis of symmetry is we need to think about the formula, x equals the opposite of b over 2a. I want to find the a and the b from our equation up here. The a is the number in front of the x squared, so that's 2, and the b is the number in front of the x, which is 8. Let's plug that into our formula, x equals the opposite of b over 2a. So we're going to have x equals the opposite of 8 over 2 times 2. Let's simplify this. We're going to get negative 8 over 4, which equals negative 2. So therefore, our axis of symmetry is x equals negative 2. And remember that this is the vertical line that cuts our parabola in half. It's going to be cut in half right where x equals negative 2. Our next step is now we're going to find the vertex of the graph. Remember that the axis of symmetry is the x-coordinate of the vertex. So if the axis of symmetry is x equals negative 2, then that means the x-coordinate of the vertex is negative 2. It's always the same number. Now we can use this negative 2, plug it into our function for both of these x's, and find the y-coordinate of the vertex. So we can write the vertex as an ordered pair, x comma y. So first we're going to start with our function, and then let's plug in negative 2 for each of the x's. Remember to follow the order of operations here. We're going to start with the exponent. So negative 2 squared is positive 4, times 2 is 8. Then 8 times negative 2 is negative 16, and then minus 1, we get negative 9. This negative 9 is the y-coordinate of the vertex. So now I can write the vertex as an ordered pair, negative 2 coming from the first part of our problem, and negative 9 coming from the second part of our problem. Let's look at another example like this, and let's let Big Ideas explain it.
Part A. Find the axis of symmetry of the graph of f of x equals 2x squared minus 4x plus 5. Notice that a equals 2 and b equals negative 4. Write the equation for the axis of symmetry, x equals negative b divided by 2a. Substituting 2 for a and negative 4 for b gives x equals the negative of negative 4 divided by the quantity 2 times 2, which simplifies to x equals 1. So the axis of symmetry is x equals 1. Part B. Find the vertex of the graph of f of x equals 2x squared minus 4x plus 5. The axis of symmetry is x equals 1. So the x-coordinate of the vertex is 1. Use the function to find the y-coordinate of the vertex. First write the function, f of x equals 2x squared minus 4x plus 5. Evaluate the function f when x equals 1 to find the y-coordinate of the vertex. F of 1 equals 2 times 1 squared minus 4 times 1 plus 5, which simplifies to f of 1 equals 2 minus 4 plus 5, or 3. So the vertex is 1, 3.